All right, kids, so today we're going to continue in section 6.5. But earlier we were talking about parallel lines. Now we're going to talk about perpendicular lines. And by the way, the symbol for perpendicularity in mathematics is an upside down capital T. So you're going to see me refer to that a lot. Now, perpendicular lines intersect at a right angle or at 90 degrees, okay? And you know how we indicate that, whoops, we got that skipping, of course. How we indicate that is something like this, with this little box. That means it's a right angle. They don't have to be horizontal and vertical. You know, it could be something like this. But as long as that's a right angle there, those lines would be considered to be perpendicular. Okay? Now, for our purposes in algebra, what we need to know is perpendicular lines have opposite reciprocal slopes. Okay, perpendicular lines have opposite reciprocal slopes. And let me explain to you what that means. Now, mathematically, opposite means different signs. So if one's negative, the other one's positive. Reciprocal means you have to flip it. So for example, if I had an equation, well, let's just do some simple things. If I have a slope of 2/3, the perpendicular slope to that would be -3/2. So you change the sign and flip it. If I had a slope of 5, remember there's an invisible 1 underneath it. So if we flip it, we get 1/5, but we got to make it negative. If I had a slope of -1, this one's a little bit weird. Remember, this is really -1/1. If I flip 1/1, I still get 1/1. But I change the sign, and the sign, of course, would be positive. So really, it's just, this is the main thing that you have to get. Perpendicular lines have opposite reciprocal slopes. Now, there's another unique case here. You know, if you have a slope that's undefined, the perpendicular slope to that would be 0. Okay, so a horizontal line, which has a slope of 0, and a vertical line, which has a slope that's undefined, they're going to be right angles. They're going to be perpendicular. And so similar to what we did with the parallel lines the other day, I could do a quick question here. You know, give equation of line perpendicular to, I'm just making this up here. We'll go with 5y minus 4x equals 30 through point -3, 8. So first thing, remember, perpendicular, the only information that we're taking from this is just the slope. We have to figure out what the slope is. We got to get y by itself. So let's move the 4x over. 5y equals 4x plus 30. Divide by 5, and you get y equals 4/5 x plus 6. Now remember, the slope of this thing is 4/5. We want to be perpendicular, so that means we have to flip it and change the sign. So the perpendicular slope would be -5/4. This is just a regular old point, so I'm going to use point slope form. Y minus 8 equals -5/4. There you go. So perpendicular lines have opposite reciprocal slopes. Now there's a worksheet with some practice problems here. Most of this is review. I'm going to go through this very quickly because you can stop and pause this as much as you want, but it should be pretty simple too. Plotting these 2 points. Remember, this is x comma y, 1 comma 2. -1 comma 0. There is your line. 2 comma 0 is here. This is rise over run. It's negative, so that means you go down 1 over 3. And there is your line. Remember, the B stands for the y-intercept. So on the y-axis, you go down to -1. Slope of 0 is a horizontal line. Okay, here, of course, you got to make sure you can plot the points. -3 comma 0 is right there. Slope is -1/2. It says parallel, so that's the same slope. Down 1 over 2. Now this one says perpendicular. The slope is this invisible 1. So the perpendicular slope, if I flip 1, I still get 1, but I have to change the sign. So I go to the point 3, 4, 3, and I have to go down 1 over 1. And there's my line. Now here I got to do a little work because I got to find the slope. So I got to solve for y. So I'm getting y by itself. And who cares what this comes out to, because the only thing I'm taking from this is the slope. It says parallel, so that means the same thing. That's the y-intercept, so I go up to 2. And then I move with the slope. It's negative, so I go down 2 over 5. Okay, now this last one's a little bit tricky. The blue one's easy. Let's do the blue one in blue ink. We're asked to give equations of each line in slope-intercept form. So I hope you find two nice points. There's one, there's one. Up 1 over 2. So the slope of the blue line's 1/2. But remember, that's not the equation. That's just the slope. We know the y-intercept, so that's good. The y-intercept's 2. So I can just say y equals 1/2 x plus 2. Now the red one's going to involve more work. Because watch this. There's two nice points, and the slope is up 1, 2, 3, 4, 5 over 1, 2, 3. My slope is 5/3. But I don't know what the y-intercept is. See, it looks like it's some kind of fractional thing between 3 and 4. Now, I can't just guess. Okay, I got to actually figure it out. So when you're in this situation, you use point slope form first. I'm going to use this point. This point is -1, comma 2. Okay? So this is going to be y minus 2 equals the slope, x plus 1. And now remember, we want it slope-intercept form, so we have to solve for y. We have to get y by itself, which means we first have to distribute. And I know it's a fraction, but it's not the end of the world. So now we add 2. And remember, adding 2, you need a common denominator. But you see, 2 is the same thing as 6/3, right? So 5/3 and 6/3 would be 11/3. And there you go. So there's a little bit more work with that one. You might have to put it into point slope form first before you can put something into slope intercept form. All right.